that's that section. The next section, we began to talk about radians and degrees, and we changed one to the other. If you remember right, halfway around the circle is 180 degrees, and 180 degrees is equal to how many radians? Do you remember? Pi radians. That was the key behind this section right here. So if I had, like for instance, if I had 255 degrees and I wanted to change this to radians, okay, this is section 13.2. What I'm going to do is I'm going to do dimensional analysis. So I'm going to get rid of the degrees. The degrees are going to have to go on the bottom. So therefore I know I've got to put the 180 at the bottom and the pi radians at the top. Well, the way that we did this is we just picked up your calculator and we did the 255 divided by the 180, got a decimal value, converted back to a fraction. It's going to give me 17 over 12, but understand I still have pi. So when you get your answer, it should have a pi in it if it's going to be in radians. So that's 17 pi over 12 radians. Y'all remember how to do that? Then if I have it in radians, let's see, like for instance, 7 pi over 4 radians. What's going to go on the bottom? I want to get rid of the radians, right? And I want to have degrees on the top. So I'm going to have to put the pi radians on the bottom, and I'm going to have to put the 180 degrees on the top. Okay, so I'm just flipping it. Now, notice I have pi on the top and the bottom, so it goes away. So literally what I'm doing is going 7 times 180 divided by 4. Oh, that's equal to 315 degrees. Okay? Y'all remember how to do that? All right, I'm going to give you one of each one of these to do. Okay? So I'm sure that you guys can do this section. So let's see. Change 65 degrees into radians and change negative 4 pi into degrees. Remember, the negative just means you're going around the circle the other way. Got it? Okay. All right, next section. This is 13.3. They actually, we did a hard way to do it, but then I showed you that there's an easy way to do it on the calculator, and you can certainly do it the easy way. It says find the exact value of each trigonometric function. So if I have the cosine of 210 degrees, I'm going to make sure my calculator is in degrees, and I'm just going to hit cosine 210, it's going to give me approximately 0.8660. Everybody good with that? But if it told me this, the sine of 5 pi over 4. Now, this is in radians, so I have to switch the mode on my calculator to radians, and then I'm going to do the same thing. I'm going to go to the sine, and then it's going to do a parenthesis, Make sure you do 5 pi divided by 4 and close the parenthesis. What did you get? Was it a negative number? Okay, negative 0.70, and I'm not sure, 71 maybe? 7071. Okay? Now, what if you have something like this? The secant of negative 30. I don't have a secant button on my calculator. So what I'm going to do is I'm going to go 1 over, what is the secant equal to? It's going to be the inverse of the sine, cosine, tangent? What is it? Not
No,
sine.
cosine.
Cosine. Remember, S and S don't go together. S and C. So then I'm going to go 1 divided by the cosine of negative 30 degrees. Do I need my calculator in radians or in degrees? Degrees. Now I've got to switch it back. Okay? So what you got? Okay, so that section is just a real easy using the calculator thing. Okay? Then we had a part of that section that did this. It said, find the exact value of sine, cosine, and tangent if the terminal side of the the terminal side of theta in standard position contains the given points. So, like if I have that it's going to contain that point, that means when I put it on a coordinate plane, I'm going to find the point 2, 5. Okay, and what I'm saying is the angle whose initial side is right here and whose terminal side is right there. Now remember, this is where you square it up, and you always square it up to the x-axis. So the x is 2, the y is 5. Remember that? This is the r, which I'm going to have to find with Pythagorean theorem. So I have 4 plus 25, so this is going to be the square root of 29, correct? Now, remember the whole thing about the sine of theta is equal to y over r, cosine of theta is equal to x over r, tangent of theta is equal to y over x. Remember all that? Okay, this is your x, this is your y, this is your r. Okay, and all you're doing is you're putting them in fraction. Now, if you have a square root on the bottom, like you would on the sine, okay, and they want the other ones too, okay, but remember that the cosecant is the inverse, so it's r over y. The secant of theta is r over x. The cotangent of theta is x over y. Now, if you struggle with this at all, this is what I would do. I would draw it out, and then I would go, oh, x equals 2, y equals 5, r equals the square root of 29. Now it's just a matter of putting it in, okay? Now, let's say I had this one, okay? Y is 5 over r, which is the square root of 29. Can I leave it like that? What do I have to do?
Multiply by the square root.
Multiply it by the square root of 29. So it's going to give me 5 on the square root of 29 over 29. Now, if the 5 and the 29 could have been reduced, I would have to do that, okay? We get that part? Remember that part? Okay, you'll have one on your homework to do like that. Okay, then that brings us to law of sines. That's literally what this chapter, you know, we're almost at the end here. Let me have you do one where you do law of sines. Make sure that you can do it. And I might even give you one with law of cosines depending on what time it is. And then I'll give you your homework. And then you can be happy that's your last homework assignment for this year. Okay. I'm going to tell you that A is equal to 50 degrees. Little b is equal to 12. And little a is equal to 10. I want you to solve the rest of the triangle, okay? And And I'm gonna do it up here while you do it at your desk. Now remember, if I'm doing law of sines, I'm not having a right angle. Make sure your calculator is in degrees for this. Good? Okay. We're going to do one with law of cosines, and then I'll give you homework. Okay? Let's do one that's a little bit more challenging, okay? You've got all the sides. A is 11, B is 13, and C is 15, okay? Obviously you're going to find angle A, angle B, and angle C. I would find angle A first, just to keep it consistent.
Why's it come out different if you solve for A and you get A and then you solve for C?
This is one that you can have two.
No, if you solve for C instead of B.
Right,
You
you
did
solve
not.
for C first,
Well, if you solve for A and then you solve using law of sine,
because
you solve for
this
C.
is one of those ambiguous triangles that can have two answers.
Because I solved for C on a couple of them and I got them wrong. When you solve for B, you get a different answer.
Right, and you really didn't get them wrong, they're just a different triangle.
Yeah.
That's why I said do it in alphabetical order and then we'll all be consistent. You know how before there's some triangles that they have two answers to?
Oh,
Those
that's
are those
two
ones that
answers.
have two answers to them, okay? And so those are what they call ambiguous triangles, and they gave you some of those, and either one of those answers actually are correct,
Okay.
okay? Does that make sense?
Yeah.
If we go ahead and solve alphabetical order,
Then-
we'll all be consistent on it. So that's why I said what I said. Are we good on this? We understand? So you use law of cosines first, then you use law of sines, and then you just subtract it from 180. Okay, this is what I want you to do. Page 816 through 818. 12 through 44 even. And then I want you to do 50 and 52. Okay, I'm leaving out the part about, one solution, two solutions, no solutions.